Okay, hi everyone. Let's take a look at this problem where we'll explore the correlation coefficient, a scatter plot diagram, and we'll also explore the coefficient of determination, which also goes by the name of the R squared or R squared value. Okay, we're looking at exam data and we have some kind of quantitative data relating to the exam. We have a list of the number of questions answered correctly appearing here, and then we also have some data relating to the attitude. And I'm not exactly sure what that means, but in terms of solving this problem, we don't need to know that. Okay, so the first question asks us, right to the left of my mouse, to compute the Pearson product moment correlation coefficient. And why don't I just put it right where my cell is? And using Excel, you could type in equal Pearson. As soon as you get some of it, it'll appear. Then hit the tab, you'll get all of that. And then it's looking there for the array 1 and array 2. Well, the array 1 appears on cell A5 to A14. Now it shows up as the word correct because this file already has a named range for that range of data. Okay, and when we highlight this range, we get the named range for attitude, which shows up as well. And then I can close out the formula and we come up with the answer, which has more decimal places than what we need. So let me format it. And the answer is 0.596. Okay, so what that means, the Pearson product moment correlation coefficient is given by the symbol R. But it's of course going to try to turn that into something for me. So why don't I do this? I'll go space R like this, so it doesn't try to turn that into it for me. Then I'll widen this a little bit and shrink this, and we're right back to where we were. Okay, now we need to construct a scatter plot. I think what I'm going to do is highlight right here and show you how we can do this with Excel. I'll go up to the, I think it's the Insert menu that has the graphs. Click on the word Scatter, and this is appearing above the screen. I'm also using the latest version, the Office 2007 version, so it could be different if you're using an older version. And I'll hit Scatter. You know what? Why don't I raise this up so you can watch what I'm doing? Okay, give me a second. I'll slide this up here. Okay, so now I'm going to highlight the range of data, and then I will go Insert, Scatter, click on Scatter, and I'll get a little graph. Now it's appearing off the screen. And at this point I'm going to slide this back down to where we were, and I'll slide the graph I'm getting over so you can see it. We'll shrink it a little bit. Okay, so there we're getting the scatter diagram that we expected to get, and those data points are about right. Now I would take the title off of these. I don't see any reason to leave that on. And we really don't need this. What we're looking at is attitude is on the y-axis. The correctness is appearing along the x-axis, and that's really all we need to do to get the diagram. Okay, then it says, does it appear to be direct or indirect? And you can visually see that it's actually moving low, going upward in an upward trend. So that tells us that when we move from a lower left corner to the upper right corner, that's a positive slope. So we're seeing a direct relationship. Okay, now I'm going to write in here the word direct. Put that over to the right so it looks better. Okay, next we'll come up with the coefficient of determination, which goes by the name of R squared. Okay, and that's a fairly common statistic. Okay, so let me move over here, and I'm going to enter the coefficient of determination, as a function called r square. And so as soon as I get to rs, we get the little message that says returns the square of the Pearson product moment correlation coefficient through the given data points. That's what we want. So we'll hit the left parentheses, and it says what are our known y's and our known x's. Well, in this case, our known y's are attitude, and our known x's are the number of exams correct. We close it off, we can hit enter, and we get another value, which is essentially, the squared result of the Pearson product momentum correlation. Now, just to prove that that's what it is, you could point to that number and say square it. So we'll take it raised to the power of 2, and we come up with the same value that we had before. Let me move this over, 0.355, okay? So we could certainly square it, or we can use the coefficient of determination. But I want to illustrate one other way we could do this. We could highlight the data range, go to add a trend line, okay? And once we've added a trend line, let me slide on over here, you could show the r squared value on the chart. Okay, and I'll also show the equation as well. And I'm going to hit close, and then I'll just move all that text so we can read it a little bit better. Okay, and what you see is there's the r squared value, which is a measure of how well that line actually fits the data points. And what we've done is we've calculated the relationship of the line. Now, because we see the line is going upward, we know it's a direct relationship. But that's just another brief introduction to using linear regression as a way to come up with the coefficient of determination. Although the purpose of this brief presentation was not to cover linear regression. Okay, that's the answer, everyone. Thank you.